when we look at these periodic graphs, and remember they really are periodic, let me show you this again, they recur over time. This bit looks the same as this bit. This bit looks the same as this bit, and it goes on to infinity if I were to change my coordinates. They're periodic. There are some properties of these functions that you need to know the names of. So, the amplitude of this function is the maximum distance it gets away from its equilibrium position, which is the value in the centre. Now, but we're going around a circle here. So the centre position is here, and both x and y go from -1 to +1. So the amplitude, the maximum distance away from the zero reference, is 1. The amplitude of this graph is 1. It goes to 1 up and to 1 down. Sorry, that's my dog. So the amplitude of cos in this case is 1. Sine is the same, remember, the maximum distance it goes away, +1 or -1. What about tan? Where was my graph of tan? Tan doesn't actually have an equilibrium position. It goes out to plus and minus infinity. You could say it doesn't have an amplitude, or it has an infinite amplitude. It does have a different property though. The other property is the period. The period of the graph is how long it takes for one complete cycle. That's my dog. The period of the graph is how long it takes before it gets back to where it started. The period of cos is 360 degrees. Sine's a bit trickier, be careful. It's not to get back from here back to there, it's to complete a whole cycle, which is up and down. So again, it's 360 degrees. But have a look at tan. The graph of tan actually recurs every 180 degrees. So the period of the tan graph is 180 degrees. And finally, let's talk about the symmetry. These graphs are highly symmetric. You can see lots of symmetries. I could put a line through the centre at 90 degrees. It's the same on this side as it is on this side. I could put a line at 180. It's effectively the same here, but it's negative what it was there. But some of these symmetries are ones we've looked at before. So remember we said sine was the same up here as it was over here. The y-coordinate's the same here as it is here. So sine of 40 is the same as sine of 180 minus 40. The sine of 40 is the same as the sine of 140. Same thing happens on the bottom. Sine of -60 or 360 minus 60, the sine is the y-coordinate, is the same as the y-coordinate, the sine value here, which is 180 plus 60. Well, 180 plus 60 is 240, and 360 minus 60 is 300. They have the same y-coordinate. Same thing happens with cos. Just be careful where. So, the symmetries here are on this side and that side, all right? This, how do I explain this? This is, although it looks like a vertical position on this graph, it's actually a cos, which is an x position. The x position at 40 degrees is the same as the x position at 360 minus 40, which is 320. So these have the same x coordinate, which is cos. So cos 40 is the same as cos 320. Same thing happens over here. The cos of 180 minus 60 is the same as the cos of 180 plus 60. The cos of 180 minus 60 is 120, has the same x coordinate, has the same x coordinate as 240. So cos 120 is the same as cos 240. Finally, the symmetry of tan is actually easier to see on its graph. Look at this. It repeats exactly every 180 degrees. So the tan of any angle is the same as tan of the same angle plus 180. Tan of the same angle minus 180. Tan of the same angle minus 360. And so on in multiples of 180. That idea we will come back to later.